Now let's do a specific example. I'm going to do this in 2 dimensions just so that it's easier to draw, but exactly the same thing applies in 3. So here's the xy plane, and I'm going to put a charge right here at the point 3, 4. So there's my charge Q, and I want to find the electric field. Let's find the electric field right out here at the point 3, 4, 5, 6, 2. So the point I want to find is where x is equal to 6 and y is equal to 2. Well, we know that the way we find that is it's going to be Q. Let's say this is 3 coulombs, divided by 4 pi epsilon. Let's say I'm in air this time. Epsilon r is 1. And then I need this distance r squared, and I need the r unit vector. So let's find it. The first thing I'm going to do is define a convenient origin. Then I'm going to draw rs, which goes from the origin to my charge. So let's write an equation for rs. Rs is how far did we go in the x direction? We went 3 units in the x direction. And how far did we go in the y direction? In the y direction, we went 4 units. If we'd had a z component, we would add that in here as well. The next thing that we do is we draw RP. RP goes from the origin to the point where we want to find the electric field. RP is equal to 6 units in the x direction plus 2 units in the y direction. Now we need to find R, or RSP. RSP is going to be RP minus RS, and so let's just do that. RP minus RS is going to give us 3 units in the x direction minus 2 units in the y direction. Let's take a look at that. Is that indeed what we have for the case? Yes, it is. Right here, this is RSP. We can see that we went 3 units right here, 3 units in the x direction, and we came down 2 units in the y direction. That is RSP. That is equal to R in this picture right here. Now we need to find the magnitude of RSP. That is R, shown right there. The way we find the magnitude is we take each of these components, we square them, add them up, and take the square root. So this is going to be 3 squared plus negative 2 squared square rooted. That is the magnitude of RSP. In order to find the unit vector of RSP, we take RSP and we divide it by its magnitude. Another way, let me just get out an eraser here. Another way that we could write our Gauss's law, or sorry, our Coulomb's law, that would be very handy is we could say that this is equal to Q over 4 pi epsilon times epsilon r times the magnitude cubed times the vector. That came from integrating this with this. So you can see that right here I have all the elements we need. Let's write this one out. It's going to be 3 divided by the square root of 3 squared plus 2 squared in the x direction minus 2 divided by square root of 3 squared plus 2 squared in the y direction. So now I have everything that I need to find the electric field. All I do is multiply this magnitude, whatever it happens to be, by this, and that's going to give me an electric field which is going to have an EX component in the x direction plus an EY component in the y direction. This is how we apply Coulomb's law with point charges using the steps that I've shown you previously.